Hey guys, I don't know if this will help you or not, but on some of these problems I thought it might help for me to walk you through them. Everybody says it's easy when you do it, Miss Hicks, so I thought I'd just put one online. Okay, so the first problem, this is on the test practice worksheet. This is problem number 39, all right? And the concept that you need to know here is that the inscribed angle is always half of the central angle when they share an arc. So let's look at the first problem here. This is letter A on number 39. What do we know? Always start with what you're given if you can. Okay, well we know that the arc distance through here is 151 degrees, and we know that the arc distance through here is 128. So can we find this remaining arc measure right here? Yes, we can. We just need to add 151, 128, and subtract from 360. And that gives us 81 degrees. Okay. All right, so that arc measure right there in the yellow is 81 degrees. Let me erase. That is not working. There we go. I'll get faster at this. Okay, so now what do? Well, we have that arc measure. We learned a long time ago that arc measure and central angle measure are exactly the same thing. So the measure of angle 1, we know right away, is 81 degrees. Once we know that, we can find angle 2. Angle 1 is a central angle because it has its vertex in the center of the circle. Angle 2 is an inscribed angle because it has its vertex on the circumference of the circle, and so we can use the fact that inscribed angles are half of the central angle when they share the same arc, which these both do. Do you see that angle 2 opens to this yellow arc, and angle 1 also opens to this yellow arc? So because of that, angle 2 is half of 81, which gives us 40.5. All right, let's look at the next one. What are we given on this problem? Well, we're given this 142 degree arc. That is the measure of this arc. Well, that also is the measure of this angle right here, 142, this angle right here, because it's the central angle that intercepts that same arc. Let's see, what else do we know? Well, I think that may be all we know. Let's try to look at what we've got. We've got, let's see, this angle 1 up here. See if I can use a different color. All right, angle 1 comes down and intercepts this arc in the same places at this point and at this point. Angle 1 is an inscribed angle. 142 is the central angle. Inscribed angles are half of the central angles when they share the arc, and so angle 1, the measure of angle 1, has to be half of 142, which is 71 degrees. Now angle 2 happens to also be an inscribed angle that intercepts this arc, the same arc, right? So if angle 1 is an inscribed angle that intercepts an arc, and angle 2 intercepts the same arc, then they are the same. The measure of angle 1 and the measure of angle 2 are both 71 degrees. All right, let's learn the next one. What are we given on this problem? Well, we're given the 77 degree arc measure. Is there anybody else that uses this 77 degree arc measure? Well, kinda, not exactly. There might be several, well, not might be, I'm sure that there are several different ways to do this problem. I'm going to show you the way that I see as most obvious. So the first thing I see is this central angle right here. This yellow angle, okay? How much would that yellow angle be? Well, it intercepts the same green arc here, so that yellow angle is going to be 77 degrees. Now, once you know that angle, you should be able to find angle 1 because they are a linear pair. Linear pairs are always supplementary. They add up to be 180. So if the yellow angle is 77, we can take 180, subtract 77, and get 103, and that is the measure of angle 1. Okay. I just noticed on my paper it says 10.3, but I think it's supposed to be 103 degrees. So my key must be wrong. I'll fix that. All right, so if the measure of angle 1 is 103 degrees, see if I can fit it in there. Sorry, I haven't done this in a long time. There we go. All right, once we have that 103-degree angle there, which there are many different ways to have found that. I just did the way that was most obvious to me. Now we also have this arc here, because if we know the central angle, then we know the arc. So this arc is 103 degrees. Okay, let's look at angle 2. Angle 2 happens to intercept this arc. Do you understand that the 103 degrees is a central angle with this pink-red arc, and angle 2 is the inscribed angle with the same arc? And so inscribed angles are always half of the central angle, so half of 103 is 51.5. So the measure of angle 2 is 51.5 degrees. All right, let's look at the next one. Okay, what are we given? Well, we're given this 52 degrees. Oops. The 52 degrees is the inscribed angle right here. So if that is 52 degrees, how much is the central angle that shares this same arc? Well, it's got to be double that. So 2 times 52 is 104. So this central angle right here is 104 degrees. All right, that means that this arc is 104 degrees, arc measure. So now we can figure out x, because we know that all the way around a circle is 360 degrees, so we know that 104 plus 74 plus 60, what does that give me? Let's see, 238. And then if we say 360 minus 238, get 122. So x has to be 122 degrees. Now to find angle 1 is an inscribed angle with an arc right here between this dot and this dot. That arc measure is 74 degrees. We know that central angle and arc measure are the same thing, and so the inscribed angle has to be half of 74, which is 37. So the measure of angle 1 equals 37 degrees. All right, the next one. Let's see, what are we given? We're given a few things here. We're given the 136 degrees, and we're also given the 116. What do I want to start with? Let's see. I think I will start with the 116. The 116 is this arc right here. It's actually the central angle measure, but we know that central angle and arc measure are identical. So I know that this is 116 degrees. Well, I can find x by realizing that this is a semicircle. Let me outline it for you. This is a semicircle. That was supposed to be a different color, and that did not work. This is a semicircle, right? A semicircle is 180 degrees. So if we simply say 180 minus 116, that gives us 64. So x has to be 64 degrees. All right, 64 degrees. Now what else can we figure out? Well, let's see. Angle 1, this is going to be a little simpler than the last one. Angle 1 is the central angle. 136 is the arc measure that also corresponds with angle 1. Arc measure and angle, central angle measurement, are the same. So the measure of angle 1 equals 136 degrees. All right, next one. We're on, let's see, this would be problem 40B if you were looking at your worksheet. Okay, let's see. These two little lines here and these two little lines mean these two arcs are congruent. And so we can tell that this arc right here is cut into two equal pieces, and this arc right here is cut into two equal pieces. All right, let's just try to figure out what we have with the numbers that we're given. Let's see, we're given the 136 degrees, right? All right, so let's work around the circle here. 136 degrees, I know that a half a circle is 180. So I know that this little part over here, part of the one congruent parts, is 44 degrees. If that's 44, I know this one's 44. And then I can use some congruency information here, or I can just do the whole circle is 360 and subtract what I have, and I should know that this bottom part is also 136 degrees. I don't really need to know that, but since I was writing, I figured I'd go ahead and finish it. Okay, so how much is angle 2? Angle 2 is the central angle for this lower 44 degrees, so it must be 44 degrees. The measure of angle 2 equals 44 degrees. Now angle 1 happens to correspond with this angle. They're the same, so it doesn't really matter, but or they're congruent, so it doesn't really matter. But it corresponds with this arc up here. Angle 1 is going to be half of the central angle, or the measure of the arc, so half of 44 is 22. All right, let's see how many more. I'm just going to do a couple more of these. Okay. Next problem. Let's see. This would be number 40C. All right, we have, let's see, angle 1. Let's see. Let's do X first. That seems not too bad. We have this 46-degree angle here. It intercepts this arc right here. Okay, so arc measure and central angle measure are the same. Therefore, we know that arc measure is going to be double the inscribed angle. So what is 46 times 2? 46 times 2 is 92. So X must be equal to 92 degrees. Okay, that's the measure of arc X. All right, so if that's 92, let's see what else do we need to know. I'm going to erase everything I have so far because I think it's going to help us see what's going on next. Next, we're going to find angle 1. We could have done this in any order. I think it's not going to matter. All right, so angle 1 is this angle right here. Ooh, that's messy. Sorry about that. And it corresponds with this arc right here. Is there another angle that corresponds with that same arc? Well, there is. This angle right here, this whole big angle. How do we find the measure of that whole angle right there? Well, we just add 46 plus 22 gives you 68. So that angle, the whole green angle right here, is 68 degrees. That's the inscribed angle. If the inscribed angle is 68 degrees, how much is the corresponding arc or the corresponding central angle? Well, it has to be double that. So what is 68 times 2? It is 136. So the measure of angle 1 is equal to 68 times 2, which is 136 degrees. Okay, let's keep working. Let's see. 44 degrees, that is part of a central angle because it has its vertex here. It intercepts this arc right here. Therefore, the arc is also 44 degrees. Who else intercepts that same arc? Angle 1 does. Angle 1 is an inscribed angle. Angle 1 is inscribed, 44 is central. They share this same arc. So angle 1 has to be half of 44. Measure of angle 1 equals 22 degrees, which is half of 44. Okay, now how are we going to find X? Well, let's see what we know. I'm sure there are many ways of doing this. I Actually, I just changed my mind as I'm thinking about it, how I want to do this. I see a half circle. I see a straight line right here, a diameter, right? All right. I see this right here as 180 degrees. I've already used up 44 of those degrees. Here's my 44 degrees. So how much do I have left to use for x? I'll have whatever 180 minus 44 is. And I believe that gives me 136. So the measure of arc x is 136 degrees. I really hope this is making sense, helping at least a little bit. Okay, let's see where to start. This one's long. This is problem 43 on the practice test, number 43. So I guess I'll start with the measure of angle 1. Okay, angle 1 is right here, obviously, and it comes out like this. Intercepts this arc. If you're ever unsure which arc it intercepts, just draw the angle all the way out, see where it touches the circle, connect those dots. That's the intercepted arc. So there's that arc is 44 degrees. 1 is an inscribed angle. Inscribed angles are half of the central angle, or also they are half of the measure of the arc. And so the measure of angle 1 has to be half of 44, which is 22 degrees. All right, let's see. What do we have next? Let's look at the angle 2. Okay, let me erase what I have so far. Angle 2, I see that intercepts, angle 2 opens up like this and intercepts here and here. So there's my angle, or my arc, for angle 2. Oh, that's messy, I'm sorry. All right. Well, if I know that information, if I can figure that arc out, then I should be able to find the angle. Does anybody else share that arc? As a matter of fact, 62 does. This 62 right here shares this arc. See how it comes in? 62 is the inscribed angle. Angle 2 is the central angle. They both intercept this same arc. I know that central angles are the same thing as arc measure, and central angles are also double the inscribed angles. And so 62 degrees times 2 is what angle 2 is. So the measure of angle 2 is 62 times 2, which is 124 degrees. Okay, let me see here. Let me write that in. 124, that's angle 2, but it's also this arc. That's 44. I need to look for x. Let's see. Okay. There are probably many ways to do this next part. I'm going to recognize first that I have this 180 degree circle here, right here. This is kind of a puzzle. Like, you can decide where to start. You know, some people start at the edges, some people start, with the corners on a puzzle. It just, as long as you get to where you're going and you don't break any rules, you're fine. So there are more than one way to do this. There is more than one way to do this, I'm sure. All right, so let's see. What would we do here? I know that semicircle that I just drew is 180 degrees. I know that from this dot to this dot is 124. So I know this arc over here must be 56 degrees. Okay, so if that's 56 degrees, that means this central angle right here is 56 degrees. If I know that, then I can find angle 2. But I know angle 2, I already found it, right? Angle 2 was 124. By the way, those two things should add up to be 180 if we're right, and they do, so that's good because they're a linear pair. What else can I figure out? Well, let's see. If that arc was 56 degrees, then I can find this inscribed angle right here because the inscribed angle is half of that. So 56 divided by 2 is 28, so this angle right here is 28 degrees. To find angle 3, I have a triangle. I know one angle is 124, one is 28. I can solve angle 3 by doing 180. Well, first I'll do 124 plus 28 gives me 152. So then 180 minus 152 gives me 28. So this guy over here must be 28. Oh, I just realized something. This is a radius, and this is a radius, and that's a radius. See, I told you there's a lot of different ways to do these. Oops. Okay, so what would I do now? Well, let's see. I might recognize, let me erase what I have here. I maybe didn't want to erase all that. Tell you what, I'll probably do another video just on this problem. Alright, so let's see. I have this straight line here. I have this half circle. Okay. Well, a half circle is 180 degrees. This part is 44. Can I figure out what I have left? Just subtract from 180, 44, and you get 136. So what is the arc measure for for arc X? The measure of arc X is 136 degrees. Okay, so what can I figure out now? I'm still needing to do, I'm going to erase what I got here. There we go. All right, so let's look back at this triangle. Kind of going in a roundabout way here. This triangle right here. I know that's an isosceles triangle because this is a radius and this is a radius. So earlier when I found angle 2 to be 124, to find angle 3 and this other one, I just say 180 minus 124 gives me 56, and then I need to divide 56 into 2 to get this angle and angle 3. So angle 3, I'm not writing properly here, I'm sorry. Angle 3 is equal to 28. I'm going to completely redo this problem on another video. So if you want to just stop watching now, that's fine. It's okay. And then how do I find angle 4? Well, let's see. I already found this. How do I want to tell you this? Okay, I think I've just made this more complicated. Let me just do this on another video. Just turn this off if you haven't already done it. I'm sorry I can't edit it. All right.